Okay, we're back for the second video in week 3. We're going to look at expectation. Just keep in mind that this is going to be in the homework. It's probably going to show up on your first test, and more than likely it's going to rear its head on your project. So you want to make sure you nail this concept. So we're going to take our time. Okay, so we've got a pizza. So here, Izzo's Pizza sells 4 types of pizza crust. So these are different types of crust. Last week, the owner tracked the number sold of each type, and this is what he found. All right, we've got thin, thick, stuffed, and pan. Based on this information, of the next 3,000 pizza he sells, how many should he expect to be stuffed crust or pan style? All right, so he wants to focus on finding out if he sells 3,000 pizzas, how many could he expect to be stuffed or pan? All right, we got this. Round your answer to the nearest whole number, which would be the nearest pizza, nearest whole pizza. And then it says here, do not round any intermediate calculations. So my hint to you is wait until the bitter end of the calculations to round. Okay, let's figure out how many pizzas we have, first of all. So pizza crust, I should say. So let's see here, 314. That's going to be very difficult to see. But I don't know why that's not showing up at all, hardly. I'm going to add 314 and 250 and 177 and 182. Okay, it's going to give me, let's see here, 923 total crusts. So I'm going to put that here. Okay, then we need to figure out how many stuffed and pan together there are. So we're going to add 177 plus 182. Okay, that's 359. Okay, so we know based on last week's tracking that 359 out of 923 total were stuffed or pan. So this is stuffed or pan out of the total. Okay, we're going to set this up like an algebra problem. If we know 359 out of 923 total pizzas were stuffed or pan pizza, then how many, that's the question mark, could he expect if he sells 3,000 total pizzas? Okay, so this is the question mark right here. This is what we're solving for. All right, that's the setup. 359 out of 923 are stuffed crust or pan style. How many could we expect out of 3,000 next week? Okay, so a great thing about this is we can use good old cross multiplication. So we can multiply these two numbers together and put them equal to this two things smushed together. So 359 times 3,000 is going to be equal to 923 times, we don't know, X. There's really a times here, but sometimes when you just smush things together, just like this, it just means that you're multiplying. Okay, so I'm going to multiply 359 by 3,000. Let's see what that is. 359 times 3,000. Okay, that's a big number. Equals 923 times X. 107,7000. We want to know what this is. So in algebra, when things are multiplying, to get rid of it, you divide. So 923 divided by 923 just cancels that out, just becomes 1x or x. And now if you do it to this side, it's not fair in life, but it is fair in algebra. We're going to do it to that side. So I'm getting 1166.847. Okay. Now, how many pizzas is that? Should we really think about that as? It says round to the nearest whole number. Okay, so that's this right here. So the 6 looks at the 8, and the 8 says to the 6, you're allowed to go up to 7. So X is equal to 1167 expected stuffed or pan next week. Okay, or out of the next 3,000. Out of next 3,000 pizzas. Okay, let's move to the next one. Let's see how you do on the next one. Mrs. Simmons is a librarian at East Side Library. In examining a random sample of the library's books collection, she found the following. 710 books had no damage, 180 books had minor damage, and 235 books had major damage. Based on this sample, how many of the 69,000 books in the collection should Mrs. Simmons expect to have minor damage? Okay, so minor damage is right here. Round your answer to the nearest whole number. Don't do any rounding before you get to the end. All right, we got this. We need to add up the total number of books in her sample. So if we add 710 and 180 and 235, we're going to get 1,125. Okay, of which 180 had minor damage. So that helps us with our setup. So 180 books had minor damage out of a total 1,125 sample books. Okay, equals how many could we expect if we were to go through the whole collection? So this was the total sample books. This is total books in the collection. So notice when you set this up, this is totals and totals on the bottom. 180 have minor. How many will have minor here? That's the question mark. All right, go for it. You're going to do cross multiplication and figure out what X is. Don't forget to round to the nearest book. All right, so if you take 180 times 69,000, we're going to put that equal to 1,125 times X. Well, 180 times 69,000 is 1, 2, 4, 2, 1, 2, 3, 4. That's a lot. Equals 1125X. And then you know what to do. Divide both sides by 1125. There might not be any rounding here because we have even numbers on the top and the bottom. Yep, we don't. No rounding. So 11,040 books out of 69,000 expected to have minor damage. Okay, so that's an introduction to expectation. Hopefully that makes sense. We're going to get into a little more difficult expected value where we're going to work with games of chance. So let's tackle that. Okay, Deborah's playing a game in which she spins a spinner with 6 equal size numbers 1 through 6. So something like that. The spinner stops on a numbered slice at random. The game is this. Deborah spins the spinner once. She wins $1 if the spinner stops on number 1. So I'm going to highlight that. She wins $4 if the spinner lands on the numbers 2. She gets $7 if it lands on the number 3, and she wins $10 if it lands on the number 4. But she loses, let's see if I have a different color highlighter on me. I do not, but she loses $6.50 if it lands on 5 or 6. Find the expected value in playing the game. Okay, this one's going to take a little bit more time. Each time Deborah decides to play the game of chance, the result is always uncertain. It isn't known how much money Deborah will win or lose. We just don't know. However, the expected value can be used to predict what could happen if Deborah plays the game many times. Okay, here's what we're going to do. To find the expected value of the game of chance, we multiply each possible result in dollars by its probability, and then add those products. Okay, I recommend making a chart. So I'm going to make a spin row, a result row, and a probability row. Okay. So let's make a little chart here. Okay, now we know that there's 6 slices here. So 1, 2, 3 that she can land on. Okay. Okay, so those are the spins. The results. Well, if she gets $1, if she lands on the number 1. So this would be a $1 she would win. She gets $4 if she stops on the number 2. I'm gonna put a little plus sign in here to show she wins that. She gets $7 if it stops on number 3. Okay, she wins $10 if it stops. That's the result. She wins on number 4. That's a plus. Now, if she happens to land on this 5 or this 6 over here, she's going to lose $6.50. So this is $6.50 here and $6.50 here. And I'm going to put minus signs in there. Okay, the probability. We know when she spins the spinner, she's got a 1 in 6 chance, right, out of winning or of landing on any certain number. So the probability is 1/6 for each one of these. Whether she lands on a 1, a 2, a 3, a 4, a 5, or a 6, that doesn't change. Okay, they tell us we must multiply each possible result here times the probability. And then at the end, we'll add up what we got out of that. Okay, so here we go with fractions here. And I highly recommend taking this slow and writing this out. In fact, I might pause the video so you don't have to watch me agonizingly write everything out, and then I'm going to unpause. So let me do that, and then I'll be back with you in a second. Okay, so here's what I did. It wanted us to multiply each result by each probability. So I have $1 times a 6, $4 times a 6, $7 times a 6, $10 times a 6, plus negative $6.50 times a 6, plus negative $6.50 times a 6. So this is where things kind of fall apart and people sort of lose steam when they're doing these problems. But I promise you, if you can get this down and you organize your thoughts and make a table, you will be able to persevere on problems like this on your test and on your project. Okay, so 1 times 1/6 is just 1/6. Okay, I'm going to do that off in the shadows here. 1 times 1/6 is really 1/1 times 1/6. And you're just going to multiply the tops. 1 times 1, 1 times 6. Same thing here. Plus 4 times 1/6 becomes 4/6. How does that happen? Off in the shadows, 4/1 times 1/6 equals 4/6. Okay, so don't be afraid of these fractions. So we took care of that and that. Plus 7 times a 6 is 7/6. Off in the shadows, 7/1 times 1/6 equals 7/6. And plus 10 times a 6 becomes 10/6. And I'm not reducing any of these because when you add fractions, you want all the denominators to be the same. So I don't want to start reducing these things. Okay, then we have negative 650 times a 6. Well, that's going to be negative 650 over 6 minus, or negative 650, however you want to say it to yourself there, over 6. All right, and I can do that off in the shadows too. So negative 6.5 over 1 times 1/6 just becomes negative 6.5 times 1 over 1 times 6, which is 6. Okay. Now, when you add fractions, if you remember, you're going to keep the same denominator, and they all are the 6. And then you're just going to add the tops. So you got 1 plus 4, is 5, 5 plus 7, plus 10, minus 650, minus 650. So go through that on your calculators and see what your numerator would be. Okay, so if you add up 1 plus 4 plus 7 plus 10, it equals. Subtract 650, subtract 650, it equals. You have 9 over 6. Okay, 9 over 6 in the calculator doesn't make sense when we're dealing with money, but if you divide 9 divided by 6 in your calculator, you're going to get $1.50. Okay, so what we did there is we're adding the products. So remember the instructions, it said multiply result times probability, which we did, and then add the products. So this is where we're adding the products. Okay, what the heck? What the heck? What the heck? What the heck does this mean? $1.50. Okay, this is the expected value that we could use to predict what would happen if Deborah plays the game many times. And it looks like, since we have a positive $1.50, that could mean something. All right, so I made a little slide to help us with that. This is the same problem that we were just working on. We found the expected value of playing the game to be $1.50. Okay, notice that it is impossible to get a result of $1.50 any particular time the game is played. Because remember, she could win $1 or she could win $4. Rather, $1.50 is just the long run average per spin of playing the game many times. That's what she could expect to win in the long run. Okay, here's some very good notes that I think you should pay attention to, maybe write down, maybe take a screenshot of this. Because what does this mean to us? If the expected value is positive, that means you can expect to win money on average per spin. So for Deborah, Deborah's very lucky. Okay, that $1.50 was positive. So she would expect to win money on average every time she spins. Now, if the expected value happened to be negative, that means you could expect to lose money on average per spin. If your expected value is 0, that means you can expect to break even, which means you'll neither gain money or lose money on the average per spin. So Deborah had best case scenario. She could expect, because we came out with a positive answer, she could expect to win money on average per spin. Okay, here's one I want you to give a try on your own. Justin has a deck of cards numbered 1 through 10. He's playing a game of chance. The game is this. Justin chooses one card from the deck at random. He wins an amount of money equal to the value of the card if an even numbered card is drawn. So he wins the amount of money equal to the value of the card if he gets an even number card. He loses $6 if an odd number card is drawn. Find the expected value of playing this game. Okay, again, you need to make a chart. This one's going to be a bigger chart than the last one because instead of 6 slices, we're rolling, or we have a deck of cards with 10 cards in it. So I'm going to create the table, and I think that you should too, to help you keep track of what the heck is going on here. All right, I've got my table somewhat set up. I've got the 10 card numbers. The probability of pulling a card out of 10 cards is 1 out of 10, any card in particular. The result was a little more tricky. So remember when they said he wins the amount equal to the number of cards if an even number card is drawn. Well, even number card is 2, 4, 6, 8, and 10. So he's going to win money. So if he pulls a 2, he gets $2, or a 4, or a 6, or an 8, or a 10. And I'm going to put plus signs showing that if he pulls those even number cards, he wins money equal to the number of the card. But if he loses $6, if he gets an odd number card, so that's 1. If he gets a 1, he loses $6. If he gets a 3, $6. If he gets a 5, $6. A 7, $6. And a 9, he's going to lose $6. So this is the setup. And now you got to go through the process of multiplying your result times your probability. And at the end, we'll add up all of those fractions. I'll be back. So set that up and I'll meet you in a minute. Oh, Lordy. Okay, so hold on here. We're getting there. So I have set up each of my result times probability. There should be 10 of these. And you might be ahead of me by now, but I'm going to try to catch you by now doing my multiplication. So negative 6 times a tenth is negative 6/10 plus 2/10 minus 6/10 plus 4/10 minus 6/10 plus 6/10. This is so crazy. Minus 6/10 plus 8/10 minus 6/10 plus 10/10. Oh my goodness. Okay. Keep your bikini bottoms the same. All your denominators are tens. That's perfect. When you're adding and subtracting fractions, they have to be the same denominator. And now you're just going to do like negative 6 plus 2, and then get that answer. Subtract 6, get an answer. Add 4, get an answer. Subtract 6, get an answer. So when I do all of this, negative 6 plus 2, minus 6 plus 4, minus 6 plus 6, minus 6 plus 8, minus 6 plus 10, I get a goose egg. I get 0. All of this cancels itself out. And so 0 divided by 10 is just equal to $0. Okay. Because remember, all of these numerators are all dollars. Okay, we just didn't put them there because it was just more messiness to kind of deal with here. Okay, so what does $0 mean? Well, for Justin, if the expected value is positive, that would mean that Justin could expect to win money. If the expected value is negative, that means that Justin could expect to lose money on average per spin, but ours was 0. So we're down here. If the expected value is 0, that means Justin can expect to break even, meaning neither gain nor lose money on average per spin. Okay, so hopefully that makes sense. They definitely take time, but it's worth it. It's fulfilling if you can just kind of muscle through it and just practice those. Okay, I think this might be our last expected value problem. No, we have 2 more. All right. Okay, so I think that's a Bugatti. I'm not sure. Somebody who's good with vehicles, you guys would probably know. Moto Win Auto Superstore is thinking about offering a 2-year limited warranty for $983 on all new cars of a certain model. The terms of the warranty would be that Moto Win would replace the car free of charge under certain conditions. Replacing the car in this way would cost Mototown $13,400. Suppose that under the warranty, there's a 7% chance that Mototown would have to replace the car one time, and a 93% chance that they wouldn't have to replace the car. So let's see if I can get this a little closer. If MotoWin knows it will sell many of these warranties, should it expect to make or lose money from offering them? And if so, how much? All right, we're going to have to dig deep on this one. Okay, let's break this down. So we know that there's a 7% chance that they're going to have to replace a car. So let's make note of that. Replace the car would be 7% chance. And to replace the car, it would cost them $13,400. So they would owe $13,400. Now, that's replacing the car. 7% chance. Now they told us 93% chance that they wouldn't have to replace the car. So would not have to replace the car. Okay, and that means they would owe what? Nothing. It would be a nothing burger if they don't have to replace the car. Okay, so let's figure out how much this is gonna. Let's talk about money here. So if there's a 7% chance that they're going to owe $13,400, let's figure out mathematically what that would be. So we could do 13,400 times, and I'm going to call this 0.07, okay, because that's 7% turned into a decimal. So that would be what they would have, 7% chance that they'd have to pay out 13,400. Let's figure out what that is. But there's also a $0 payout times a 93% chance. Okay. This one's easier. 0 times 0.93 is just 0. This one here, I'm gonna have to do my calculator. Okay, so 13,400 times 0.07 is $938 plus zero. So what are we looking at here? There's a $938 fee that Moto Win Auto Superstore should expect. This is the expect part here, to incur. So they would, Moto Win should expect to incur $938 cost on each car. That's that expected value here. Okay, here's the plot twist. They are going to sell people, we never even thought about this, so I'm just coming back to that. They're going to sell people this warranty for $983. So, but plot twist, let's see if I can write this out nicely here. But they sell the warranty for $983. Okay. So they've taken a risk that they could expect to incur $938 costs in each car. But but each warranty that they sell, they get $983. Let's figure out the difference between the two. 983 minus 938 equals $45. And that's positive number. Okay, so positive we know from looking at our games of chance. Let's go back here. If the expected value is positive, it means you can expect to kind of come out on top, right? Or win. So what does this mean for this Moto? So this $45 positive means in the long run, Moto Win can expect to make $45 on each warranty sold. Okay, so they're probably going to take that risk. There's only a 7% chance they're going to have to pay out this much, but a 93% they're not going to have to pay out anything. And they're selling the warranty for more than that risk that they're taking that they expect to take, then they're still coming out positive. So hopefully that makes some sense. We'll try one more. Okay, the Brady and Matthew Camera Company has just come out with their newest professional quality digital camera, the ToughPix One. The company is selling this camera only through its new mobile app at a profit of $221 per camera. I'm going to highlight that. The purchase comes with a guarantee that barring gross negligence, like somebody throwing it purposefully on the ground or dumping it in water, if the camera happens to break in the first 2 years after the purchase, Brady and Matthew will replace it free of charge. Replacing a camera in this way costs the company $4,900. Suppose for each ToughPix One, there is a 3% chance that it will need to be replaced exactly once, and a 2% chance that it will need to be replaced exactly twice, and a 95% chance that it will not need to be replaced. Oh Lord, this is a lot going on. If Brady and Matthew know that it will sell many of these cameras, should it expect to make or lose money from selling them? How much? Okay, let's compute some expected value here. Let's see what we got. So we know that there's a 3% chance, right? Because I think here, 3% chance that they would have to replace it once. Okay, so that they would owe. Now to replace it once is $4,900. Okay, that's one thing to note. There is a 2% chance that they'll have to replace it twice. So 2 times the 4,900. Well, that could get kind of expensive for them. But there's also a 95% chance they'll never have to replace anything. So we could say 95% chance that they will owe $0. All right, let's turn this into, let's figure out each of these. Okay, so we're gonna have to turn these decimals, or excuse me, these percentages into decimals. So 0.03 times 4,900 plus 0.02 times, now 4,900 doubled is 9,800. I'm gonna put the dollar signs on here so we don't forget we are working with money. Plus 95% chance that they're gonna owe $0. Okay, let's see what this totals up. So 0 times anything is always 0. 0.03 times 4,900, I'm gonna need my calculator for that. And 0.02 times 9,800, I'm gonna need my calculator for that too. Okay, so $147 plus $196 plus 0 is $343 for each camera. So it will cost them approximately, we expect $343 expected on average per camera sold. On average. But here's the plot twist. Remember, they said that they make a profit of $221 per camera. Okay. So, ... If we know that they're going to make $221, but they're going to expect to lose on average $343, this looks like a losing proposition to me. If we take $221 profit minus $343 of what we expect to lose per camera, so this is profit per camera, what we expect to lose per camera, we are looking at a negative $122. Okay, what does the negative mean? We know, let's go back to the previous slide. If the expected value is negative, that means you can expect to lose money, okay, on average. So what does it mean for Moto? Excuse me, for the Brady and Matthew Camera Company? So in the long run, this is not a good deal. In the long run, they should expect to lose $122 on each camera sold. That's not going to be good for business. Okay, so thanks for bearing with me. I know this was a long lesson on expected value. Just keep in mind, it's really, really important that you nail these because you're definitely going to see them on the test, I think, and you're more than likely going to see something like this on your project. So go tackle these in ALEKS. You can do it. Until the next video, I'll see you soon.